Now that we've added the constraints to our simulation, we can go ahead and add a few more manually art-directed parts of the sim. Now, if we take a look at this simulation so far, you can see the area that his hand is hitting at the beginning is doing nothing. And it would be really nice if we could see him really grab onto this section of the building and tear it down very deliberately instead of just knocking it away with collisions. So I'm going to actually use his hand to animate those pieces and treat them as static animated pieces until we want them to be live simulated objects. Now to attach that section of the building to his hand, we're essentially going to do the same thing that we set up in that week 4 define clusters section, where we created that test grab anim subnet to point deform that section of the building to his hand. So you can copy that point deform setup and then go back to your sim setup. And I'll just delete this measure fracture for the proxies and paste in this point deform here. Now since we only want to point deform the section that his hand is grabbing, I'll add a split node to break off that section. And in the split, I'll specify at clump equals 10,001. So if you display that, and I'll also turn off the template display for the static building for now, you can see that's correctly isolating that section. And I'll attach that to our point deform. And you can see that that section is now always attached to his hand. Now we don't want this building section attached to his hand the entire time, of course, so I'll use a blend shape to control that attachment. And I'll create a null just for the hand section to make this a bit more visually clear. And I'll connect the hand section null to the blend shape and that point deform to the second input of the blend shape. So now you can blend between the positions very easily with this slider. And I'm going to use a frame expression to do a quick animation, and you could just do a switch potentially to switch between the animated position and the normal static in place position. But I feel that it could potentially be a little bit more smooth if we blend it over the course of a couple frames instead of it being abruptly static to moving with the hand. So in this blend one parameter, I'll type fit at frame from 1003 to 1005, and that blend value will go from 0 to 1. Animating parameter values with a fit function like this is far more convenient in my opinion than setting keyframes, because we can just easily change the frame start and end here and those weight values, rather than setting keyframes and moving those around and changing those in an editor. So now you'll see that the building is in place until we want it to follow his hand, and we could just leave our animation as it is, but if you want to, you could also dent in this section a little bit upon impact with his hand for a little bit more realism and interesting interaction there. And there are various ways that you could apply that sort of denting in animation, but one option is to create some proxy geometry that we'll use to push those pieces in. So I'll start by making a little bit of room in my setup here, and I'll drag this animation to the side, and then I'll do a shrink wrap for this hand section, which will just create a simple mesh wrapping around that geometry. If you want this shrink wrap to be more accurate and to fully wrap around all the edges of that geometry, you could unpack it first, but in this case, since we're just using this shrink wrap as a rough shape to dent in those pieces, I was fine with leaving this as it is. And I'll change frames to get his hand out of the way so that we can see our work a little bit better. And then I'll subdivide this shrink wrap for a little bit more resolution and smoothness. And let's flip it to wire unshaded so that we can see this mesh a bit better. And that's kind of a messy mesh, so I'm going to convert this to VDBs with VDB from polygons, and then perhaps smooth this out even more. I'll drop in a VDB smooth, maybe turn up the filter voxel radius and the number of iterations, and then we'll convert this to polys with the convert VDB. and select polygons from that convert to parameter. And you can see this gives us a much nicer mesh that we can use to deform those building pieces. So now that we have this basic deformer shape, we can go ahead and start sculpting our dent. Perhaps we want to add a little bit of noise to this as well. So you could drop in an attribute noise, set the attribute to P, turn on center noise, and I'll just, for convenience, copy this amplitude X parameter, paste the relative reference to Y and Z so that I can control this a little bit more easily. I'll go with a slightly lower amplitude of about 0.3, maybe element size of 2, and see what that looks like. And this looks like enough noise to create a little bit of random rotation and variation on our surface. I just want to go subtle with it at this point. Next, I'm going to group a section of that sphere to push inwards for our dent, and I'll need to make a little bit more room here. I'll bump this stuff up, and I'll drop in a group, and I'll call this group push. And then I'll use this bounding sphere to define the section of our geometry that we're going to push in. Of course, for this group to work, we'll have to turn off the base group, set the group type to points, turn on bounding regions, and set it to bounding object so that it selects all these points here. And then I'll use a soft transform to push in that grouped area. Select push from our group dropdown. For convenience, I'll add the centroid as the translate pivot. So I'll type in centroid of input 0 and d_x for that x dimension. And I'll copy that and paste it in for both y and z, changing that to dy and dz. And then you can use these transform handles to dent this in to your liking, or just edit those values manually. And then I'm going to increase this radius. Right now we have a pretty harsh fall off for our soft transform. Doesn't look too terribly soft just yet. So if you increase this, it looks like a value of 2 is pretty decent. And I'll set that distance metric to radius, which will give us a slightly smoother result. And then to drive our building geometry with this, we'll essentially do the same thing that we did before. Drop in a point deform node and connect our hand section to the first input. We'll connect our basic shape without the dent sculpting into the second input, and our indented version into the third. So you can see this is denting in that section of the building pretty nicely. And then I'll use another blend shape node to animate this. We'll connect our hand section to that blend shape and the point deform to the second input. And of course, you don't have to use that fit function. Perhaps in some cases you might want a non-linear blend, or you might want to add a couple keyframes. So in this case, maybe I'll go to frame 1001, then Alt-click that blend 1 parameter to set a keyframe. Then at the main impact frame of about 1004, we'll increase that blend to 0.8, and Alt-click again to set another keyframe. And then a couple frames later, at 1006, we'll back off on this blend a little bit and turn it down to 0.6, and Alt-click again to set a keyframe there. You can Shift-click to pull up the animation editor for that parameter, and Space G to focus on that curve. And in cases where it really makes a difference, you could play around with these tangents, but in this case, I think these default tangents will be just fine. And now to combine this impact dent with the point deform that attaches it to his hand, we can just grab the output from this impact blend shape and attach that to the point deform that we're using to grab the section. We'll rename these for clarity as well. And we'll also use this dented shape for the first input of that grab section blend shape as well. So you can just grab that wire directly and connect it to our dent shape. And this will work pretty nicely because it'll ensure that it preserves that dented shape as it's grabbing this whole section and moving it around. So if you display that grab section blend shape, you can see both of those deformations layered together. Now, none of this animation is going to make any difference if we don't tell the simulation to use that animation. And if you refer back to our RBD packed object doc, one of these point attributes that you can specify here is animated. So we'll just add a point wrangle after our blend shapes. I'll call this sim attributes animated. And then for the vex, I'll just type I at animated is equal to 1. So now we can merge this back with the rest of our proxy geometry. So if you go back to the split for our grab section, you can drag this wire from the first to the second output, and we'll drop in a merge, and you can connect our animated pieces to that merge there to combine it back with the rest of the building. You'll notice that when we merge these sections of the building back together, it's complaining about a mismatch of attributes, and the only attribute difference here is the animated attribute, and we don't have to really worry about the mismatch in this case because all of those pieces that we haven't specified the animated attribute on before will just get a default value of 0, which is exactly what we want in this case. We don't want the other sections of the geometry to be specified as animated, but you do have to watch out in general anytime that you're merging together different sets of RBD objects. You just have to be aware of any attribute mismatches and default values that might be applied to your objects. Now, although we've specified that this is animated geometry, if this is an active object, it won't follow that animation at all. It'll only follow animation when it's a static object. So we'll have to make sure that we specify these pieces as active equals 0 until a certain frame when we want them to have the simulation take over. In this case, I chose to have the sim take over for these pieces at frame 1026 so that this could all fall apart at this frame. So on our sim attributes wrangle, we'll just add a little bit of extra vex to our activation here. And I'll add an if statement that checks if the clump is equal to 10,001. And if it is, then it'll set that active value based on whether the frame is greater than 1026 or not. And finally, since we're just going to let those pieces crumble at that point, we can just delete the constraints that are used for that section of our geometry. So if you go to our constraint network here, you can drop in a blast node just before the constraints null. And in that blast, type at clump is equal to 10,001. Then set the group type to points, and that'll remove the constraints for that section that he's grabbing onto. So now our grab section is all finished, and we can move on to setting up some of the manual controls for this section that we'll set up a delayed activation for toward the end of the sim.